Okay, so on Tuesday, we were talking about completing the square. Any questions on that process? So today we're going to use that process in context of circles. Before I get started though, this is actually the last lesson before the test. The test will be Monday. And so tomorrow we're just doing the test review for extra credit. That's it. Okay, so this is the last topic before Monday's test. So today we're going to talk about equations of circles again. So remember, the equation of a circle is x minus a squared plus y minus b squared equals r squared. And we talked about two different types of questions. We talked about questions where they give you a graph or a description of a circle, and you have to just figure out what the center and radius are, plug them into the formula. The answer is the equation of the circle. And then there were questions that went the opposite way, where they gave you the equation of a circle, and they wanted you to find the center and radius or graph it or describe it in some other way. And so the question we're going to address today is, what if the equation of the circle is not in standard form like this? Like, for example, suppose I have a circle that the standard form equation is x minus 2 squared plus y plus 1 squared equals 9, something like that. Like, I can easily find the center and radius of this circle, right? The center is 2, negative 1, and the radius is 3, correct? But what if this equation was all FOILed out and everything was on one side? Like, for example, what if it was x squared minus 4x plus 4 plus y squared plus 2y plus 1. I'm just FOILing now. Equals 9. And then what if everything was just combined on one side? So what if it was x squared plus y squared minus 4x plus 2y, and then if I combine all the constants, I have 4 plus 1, and then minus 9 is negative 4 equals 0. I think you'll all agree that this equation right here and this equation right here are equivalent. They're the same thing. All I did is I just multiplied out the parentheses. I just FOILed everything out. But the question is, how can you get from here to there? Like, what if this is the way that they gave you the equation, and they said, here's an equation of a circle. What's the center and radius? You got to get it into that form. So this involves completing the square. Okay, so here's the deal. So this is if equation of a circle is in general form. Okay, in these two equations, the top one here is standard form of a circle. This bottom one is called general form. They're equivalent to each other, but you got to be able to get from one to the other. It's easy going from standard to general, you just FOIL, but it's a little more challenging going from general to standard. So the equation of a circle is in general form. So let's do an example. Let's actually do this example. Why not? So if I have something like x squared plus y squared minus 4x plus 2y minus 4 equals 0. Step 1 is to group together x's and y's on the left and move the constant to the right. So I'm going to group together the x's. Well, the x terms, if you look at this, are x squared minus 4x. I'm going to group them together. So I'm going to have x squared minus 4x. The y terms here are y squared plus 2y. So I'm going to group them together. And I'm going to move the 4 over to the other side by adding 4 to both sides. The next thing you're going to do, step 2, is to complete the squares, plural. There's 2 squares here. There's an x term square, and there's a y term square. I'm going to complete both the squares. Complete the squares in x and y. So that looks like this. I have x squared minus 4x, leave a little bit of space, plus y squared plus 2y, leave a little more space, equals 4. To complete the square in x, I'm going to take half the coefficient of x. What's that going to be? What's half of the coefficient of x here? -2. So I'm going to add -2 squared here. And I have to add the same thing over here, -2 squared. And then to complete the square in y, I'm going to take half the coefficient of y, which is 1, and I'm going to add 1 squared to both sides of the equation. And then remember, the way that we pick that number by taking half the coefficient of x and squaring it makes this here factor as x minus 2 squared, right? It's whatever this number is, or term is, plus whatever this term is. Same thing goes for the y's. These 3 terms are going to factor as y plus 1 squared. It's whatever's here plus whatever's here. And then on the right side, I can just simplify. 4 plus 4 plus 1 is 9. That's it. It's in standard form now. I can easily pick out the center and radius. Center is 2, -1. The radius is 3. And that's the answer we should have gotten up here, right? That's the same answer that we started with up here before we FOILed it. So you can see that completing the squares process is really fundamental in being able to do this. Once you get here, you're done. The center is 2, -1, and the radius is 3. Done. All right, let's do a couple more examples. How about this one? X squared plus y squared plus 8x minus 2y minus 64 equals 0. So I'm going to group together the x's, x squared plus 8x, leave some space, group together the y's, plus y squared minus 2y, leave some space, equals 64. That's the first step. Just group together the x's, group together the y's, and move the constant over to the other side. Now you complete the squares. So if I take half of 8, 4, I'm going to add 4 squared to both both sides. Do the same thing with the y's. Half of -2 is -1, so I'm going to add -1 squared to both sides. Everybody okay with that? So then on the left, these terms factor as x plus 4 squared, and these terms factor as y minus 1 squared. And if you look at the numbers here, 64 plus 16 is 80, plus 1, 81. So the center of this circle is -4, 1, and the radius is 9. This is r squared, so the radius is 9. I would say the most common mistakes that people make are sign errors. Like they'll forget that this is actually -1 squared. Okay, so just be careful of sign errors. Let's do one more example. How about this one? X squared plus y squared minus 16y minus 36 equals 0. So what's unusual about this problem compared to the previous two problems we've done? Yeah, there's no other x term. What does that mean in terms of like coordinates of the center? It just means it's 0, right? It means the x value of the x coordinate of the center has to be 0. So if I group together the x's, I just get x squared. If I group together the y's, I get y squared minus 16. Y. Leave some space. 36. So this one only has one square that needs completing, right? The y's. The x's is good. It's just the y's. So I'm just going to add -8 squared here and add -8 squared here. So that's just x squared. These terms factor as y minus 8 squared. And then 36 plus 64 is 100. So the center of this circle is 0, 8, and the radius is 10. Any questions on that? That's all there is to it. That's just completing the square to find the center and radius of the circle. Okay, so tomorrow we'll do just a test review handout for extra credit. There won't be a recorded lesson or anything like that. And then Monday will be the test. Yeah, there won't be a lesson that day either. Everything since the last test. So that included everything about circles. So we had like arc formulas, and this is on, it's going to be on Google Classroom today too, but we had arc measure. So there was two formulas that dealt with that. If you have a central angle, like this, a central angle equals the measure of its arc, right? So if this is like A, B, C, the measure of angle ABC equals the measure of arc AC. And then we had an inscribed angle that looks like this. And for an inscribed angle, the measure of the angle is half the arc. So the measure of angle ABC is half the measure of arc AC. Then it's everything that was on yesterday's quiz, which was last week's stuff. So that was segment lengths in circles. And there's three formulas here. We have, if you have two chords intersecting inside a circle, then the product of the segments of one chord, A times B, equals the product of the segments of the other chord, C times D. Two secants intersecting outside the circle. So for this one, the whole secant, A plus B, times the outside part equals the whole secant here, C plus D, times the outside part. And then the third formula was we have a tangent and a secant. So the whole secant, B plus C, times the outside part equals the tangent squared. Then we talked about constructing a tangent line. Equation of a circle. That's just looking at a graph and being able to give the equation of a circle based on its graph. Then we did equation of a circle with distance formula. That's where instead of giving you the radius directly, they'll give you like the center of the circle and a point on the circle, and you have to use the distance formula to calculate its radius. Or maybe they give you endpoints of a diameter, and you have to use the distance formula and the midpoint. Then completing the square, that's what we did Tuesday. So that's just generally like knowing what the process is, like what's the number you have to add to both sides. It's half, it's half the coefficient of x squared. That's the number you're adding to both sides. And then today, which is more equations of circles. So complete the square, and then also to find center and radius. If they give you a circle that's in general form, you need to be able to put it into standard form. Okay, so it's basically everything about circles here. Okay, any other questions?